Hi students, today we will discuss about the two types of vectors. It is a continuation of the two previous lecture. We will see that what are the types of vectors. The first one is parallel vectors or like vectors. Second one is anti-parallel vectors or unlike vectors. Third one is the negative vector. Fourth one is co-initial vector. Fifth one is co-linear vectors. Next co-planar vectors, equal vectors, unequal vectors, null vectors, position vector, unit vector, displacement vector, polar vector, axial vectors. These are the types of vectors. Now we will go to discuss about each type of vector. The first one is parallel vectors. We will see what is a parallel vector. If two or more vectors are parallel to each other, then those vectors are called as a parallel vectors. It means the angle between both vectors are 0 degree. If theta equal to 0 degree, then those vectors are called as a parallel vectors. Here parallel vectors means both vectors are acting in the same direction. Both vectors are acting in same direction. This is also acting upwards, it is also acting upwards. Then the vectors are called as a parallel vectors. Here two or more vectors are called parallel vectors. Its condition how to take means angle between vectors are both are acting in same direction. If both vectors are acting same direction, then the angle between the vectors is 0 degree. Both are acting same direction means angle between them is 0 degree. Then the vectors are called as a parallel vectors, or one more word is like vectors also it is. Next, the second type is anti-parallel or unlike vectors. Here anti-parallel or unlike vectors means two vectors representing the same physical quantity. Representing the same physical quantity means actually these two vectors will take either displacement vectors or force vectors or acceleration vectors. Like same vectors you can take. One is the velocity, another one is acceleration, don't consider. One is the velocity means another one also velocity. First one is the acceleration, second one also acceleration. This A bar represents acceleration vector, B bar also represents acceleration vector only. That is mean of representing same physical quantity. Next, two vectors are called unlike vectors if they act in opposite direction. However, their magnitudes can be different. However, their magnitudes may be equal or not equal also can take. But both vectors are acting in opposite direction. Here this vector acting upward direction, this vector downward direction. Here anti-parallel or unlike means the value of theta equal to 180 degree. The value of theta equal to 180 degree. If angle between two vectors is 180 degree, those are called as anti-parallel vectors. If angle between two vectors is 0 degree, those vectors are called as a parallel vectors. Next, the third one is negative vector. What the negative vector means? A vector having the same magnitude and opposite in direction to that of a given vector is called negative vector. Here A bar is the given vector. A bar is the given vector. For example, A bar acting towards right. A bar vector acting towards right. Here arrow represents which direction acting. Next, its negative vector means exactly opposite, same magnitude. Both are having that same length. In this diagram also observe A bar vector length minus A bar vector length both also same. But this vector acting opposite direction of a given vector. Now angle between these two also 180. Those vectors are called as a negative vectors. But negative vector anti-parallel vector difference is what? In anti-parallel vectors either magnitude of vectors are same or different. But here magnitude of vectors are same, but direction only opposite. That is the difference between negative vector and anti-parallel vector. Next, the third one is co-initial vector. In this only have what is that to mean? co-initial. Co-initial means common initial point. The vectors are having that same initial point are called as a co-initial vectors. The vectors are having same initial point are called co-initial vectors. Here these all vectors here are taken a bar 1 vector, b bar 1 vector, c bar, d bar, e bar. These all are starting from that O. This vector is OA, this vector is OB, this vector is OC, this vector is OD, this vector is OE. But these all vectors initial point is same. That's why those vectors are called as a co-initial vectors. Co-initial means to common initial point. Then the vectors are called as a co-initial vectors. The next one is co-linear. Here also in this only have its meaning. Co-linear vectors. What is the co-linear? Co-linear means linear vectors to co-linear, common direction it is required. Here a bar 1 vector, b bar 1 vector, both are in the same line, have see that. These are not a parallel, both are in that same line also. A vector acting which line, b vector also acting in the same line. These vectors are called as a collinear vectors. Two or more vectors are said to be collinear when they are act along the same line. When they are act along the same line, however their magnitudes may be different. Maybe their magnitudes are different or magnitudes are equal. Whatever may be their magnitudes, magnitude is not an important, but both vectors are in the same line, have or not. वही देखना है कभी भी. Here a bar vector, b bar vector, these two vectors are in opposite direction acting, see that, but direction opposite here, but same line acting. Then these also considered as a collinear vectors. These also considered as a collinear vectors. Either magnitudes however may be and direction may be same or opposite also can take, but line of action is same. Then those vectors are called as a co-linear vectors. Next, the next one is coplanar vectors. Coplanar means nothing but all vectors are in that same plane. Here see, a number of vectors are said to be coplanar if they are in the same plane or parallel to the same plane. However, their magnitudes may be different. Magnitudes whatever may be can take. It is x-axis taken, it is a y-axis. It means this plane name is called as xy plane. In xy plane taken as a three vectors, a bar vector, b bar vector, c bar vector. It is a bar vector, b bar and c bar. Three vectors are taken. But these three vectors are in the plane xy only. That's why these vectors are called as a coplane. First vector where have means xy plane. Second vector where means xy plane only. Third vector where means xy plane only that. That's why these vectors are called as a coplanar vectors. Otherwise, instead of xy you can take in yz plane also. Otherwise, in xz plane also you can take. But all vectors are in that same plane only that. For example, ground also you can take. Ground is act as a this base. This base act as a one of the plane. On the plane any number of vectors can take. Those all vectors are whatever may be the direction, whatever may be their magnitude, but you are taking that same plane means those vectors are called as a coplanar vectors. The next one is equal vectors. Equal vectors mean if two vectors are having equal magnitude and same direction. Equal magnitude required, same direction required. These are 2 points also. One is the equal magnitude, second one is the same direction. Then the vectors are called as a equal vectors. It means both vectors are having the same magnitude. Magnitude represents modulus of a bar. A bar is the given vector, its magnitude is modulus of a bar. B bar is the another vector, its magnitude is modulus of b bar. Both are having the same magnitude. It means modulus of a bar equal to modulus of b bar. In this diagram you are observe, both are in the same direction, both are having the same magnitude, then these vectors are called as a equal vectors. The next one is unequal vectors. We will see this. If two vectors have either magnitude or direction, or both magnitude and direction are different here, and both magnitude and direction are different, then the vectors are called unequal vectors. Magnitude different also unequal vector, direction different also unequal vectors, and both magnitude and direction different also unequal vectors. In the first diagram we will see actually maybe both are have the same length. It's mean magnitude is same maybe, but direction is opposite. That's why these vectors are called as a unequal. In this, both are in the same direction, parallel vectors. Here theta value is 0 degree, but both are having the different magnitude. That's why these are unequal vectors. Here magnitude different to direction also different. Theta value 180. Here modulus of A is not equal to modulus of B. Magnitude of A is not equal to magnitude of B. Maybe here magnitude of A equal to magnitude of B, but direction theta value is 180. Then these vectors also called as a unequal vectors. Any one will be different, either magnitude different or direction different, or both magnitude and direction will be different. Then the vectors are called as a unequal vectors. The next one is null vector. What is a null vector? A vector whose magnitude equal to 0. A vector whose magnitude is 0. It is called as a null vector. There is no magnitude. Okay, for example, there have the one point. What is the magnitude of the point means? Generally the point is not visible. What is its magnitude means? It is very closer to 0. That is not able to define like. Those vectors are called as a null vectors generally. For this with examples also we will explain. But its direction is indeterminate. For this point, which direction will take? You can take for this point right side, left side, up, down, any direction also can take. That's why it is not have any specific direction that. Its way. That's why here write as a indeterminate. Indeterminate. The direction is not able to say any specific direction. Next example we will see the velocity of a particle at rest. If the particle at rest, what is its velocity? Velocity equal to 0. The particle at rest means its velocity equal to 0. Velocity 0 means magnitude is 0. That's why that vector is called as a null vector. The acceleration of a particle moving at uniform velocity. The particle is moving with uniform velocity. Moving with uniform velocity means velocity constant, but acceleration A equal to change in velocity upon time. Acceleration A equal to rate of change of velocity or change in velocity with respect to the time. Velocity constant or velocity is uniform, then change in velocity equal to 0. 0 by time, 0 that is. Acceleration is 0. Acceleration 0 means that vector is called as a null vector. The particle is moving with uniform velocity, then acceleration is called null vector. If the particle at rest, then velocity equal to 0, that's why velocity is called as a null vector. Next, the displacement of a stationary object over any arbitrary interval of time. Any arbitrary interval of time, the displacement of a stationary object. Stationary object means it is not moving. Any time interval you are taken, displacement equal to 0 only, because of that is the stationary object. Displacement 0 means then the displacement is called as a null vector. Next, the position vector of a particle at the origin. At origin means what is its position can say 0 that is. That's why the position vector means 0 I cap can write at origin. That's why it is also called null vector. Otherwise, some more examples also can give for this. What are the examples? For example, one body is projecting upwards with velocity u. A body is projecting vertically upwards with velocity u. It is moving certain height. It is moving certain height. It is reached to the particular height. Their velocity equal to 0. And when it is moving upward direction, the velocity of a body decreases. After some time, its velocity will be 0. Then again it is come back. It is reached to the same position. For that, the time taken is called as a time of flight actually. After time of flight, the particle is reached to that point of projection. Then its displacement you are taken 0 only. then displacement is considered as a null vector. Otherwise, one particle is rotating along the circular path from here started, again it is reached to that same point after one rotation. After one rotation, what is the displacement? 0, because of initial position, final position of the particle, both are will same. Initial position of the particle, final position of the particle, when both are coincident, then the displacement of a particle equal to 0 only, that is. Like many examples can take about this null vector. Null vector means what? The vector quantity magnitude equal to 0. Then those vectors are called as a null vectors. Next, position vector. What the position vector means? Generally, before going to this explanation, some examples we will discuss. Generally, what is your position? You are saying, in case you are doing any job also, you have one designation. Based on your designation only, you are saying my position. Otherwise, GM, AGM, otherwise one of the coordinator, one of the section coordinator, like. So you are saying one of the designation, that is your position represents. Similar way here also in physics, what is the position vector mean? Any point you are taken, what is its position? For that, a vector that represents the position of a point in a magnitude and a direction. A vector that represents the position of a point in magnitude and direction with respect to a coordinate system. With respect to the coordinate system is known as position vector. Here one of the point is taken in this coordinate system. Here taking coordinate system is x, y, z. 3-dimensional coordinate system is considered here. In a 3-dimensional coordinate system, one point is taken, it means in the space it is. 3-dimensional coordinate system means if any point is taken in the space existed that. Now this point P is taken in a space. This position is with respect from the x-axis x, with respect to the y, with respect to the z, the position is z. That is why this coordinate is given as a x, y, z. That is the position of the particle x, y, z. Here actually this is the O, this is the P. This OP equal to can take as a R bar. OP bar equal to can take as a R bar it is. OP bar can take as a R bar. We will see that OP equal to R bar. But R bar vector how to represent here? Actually unit vectors are there. Next coming that unit vector. Along the x direction unit vector I cap. Along the y direction unit vector is j cap. Along the z direction unit vector is k cap. I cap is a unit vector. I cap represents x magnitude acting along the x direction. J cap represents any magnitude acting along the y direction. K cap represents any magnitude is acting along the z direction. Here the coordinate of position P is x, y, z. With respect to the x, position vector of P with respect to with respect to the origin is, here all positions are measuring with respect to the origin. All positions are measuring with respect to origin only that. That is why here given position vector of a point P with respect to origin is R bar equal to x I cap, y j cap, z k cap. It means x magnitude along the I cap represents this magnitude acting along the x direction, y magnitude along the y direction, z magnitude acting along the z direction, that is. How to take the magnitude of position vector means, for given vector this magnitude always will take as a, the symbol is modulus of R bar, that is equal to under root x square plus y square plus z square it is. For example, one of the vector coordinate is given as a, that position of the point P is 1, 2, 3. Simply taken 1, 2, 3 the position is. For this the position vector will write R bar. R bar equal to 1 means what? First one is the x coordinate, second one is the y coordinate, third one is the z coordinate. That is why I write 1 into x coordinate, one acting x direction. How to represent means I cap will be represent. I cap you are writing means that one acting along the x direction only, plus 2 j cap plus 3 k cap. The magnitude 2 acting along the y direction, the magnitude 3 acting along the z direction it is. Here 1 I cap, 2 j cap plus 3 k cap. Then the modulus of r, the modulus of r bar equal to under root 1 square plus 2 square plus 3 square, that is equal to under root 1 plus 4 plus 9, that is equal to under root 14. That is the magnitude of the vector. Like any coordinate, if you know, you can write its position vector. It's mean the position of point P with respect to the x axis how much, with respect to the y axis how much, with respect to the z axis how much. Without a coordinate system, you are not able to explain any position of the particle in the universe. You are taking compulsory one of the reference for explanation. For example, where are you? If I am asking, if asking anybody in a college, any person is asking, you are saying in a classroom. But from outside anybody is asking, you are giving answer is I am in the college. Are you clear that? From outside anybody asking, you are saying the answer where are you means I am in the college. But in college any person is asking, in college particular position I will say, and that is one of the classroom, in the second year class or in the first year class, otherwise in the first floor or in the second floor in this building, like that building or classroom, these all also called as the reference points. Without a reference we are not able to explain anything also. That is why here for explanation of the position also we will take origin. Without origin position, origin point, not able to explain the position of any point. Be reminded that. Next, the next one is unit vector. What is the unit vector means? From this only you can understood unit. Unit means 1. A vector whose magnitude equal to 1. A vector whose magnitude equal to 1 and use it to specify a convenient direction. Specify a convenient direction is called unit vector. It is have the one specific convenient direction also and magnitude is equal to 1. Always unit vector magnitude is 1 only, that is. Next, I cap is unit vector along the x axis, j cap unit vector along the y axis, k cap unit vector along the z axis. In the previous also, in the position vector based also we are taken I cap, j cap and k cap. I cap represents unit vector along the x axis, j cap unit vector along the y axis, k cap unit vector along the z axis. If a bar is a non-zero vector means other than 0, 0 vector, then its unit vector is given by, if it is a non-zero vector, its unit vector. Unit vector is denoted with the cap. Generally, vector notation how to take a bar, but unit vector notation how to take means a cap it is. This is notation of unit vector, representation of unit vector otherwise. Here a cap equal to a bar by modulus of a. Here observe why taking this form a bar by modulus of a. Here a bar vector magnitude for example taken modulus of a only. Denominator what have? Magnitude of a. Both magnitudes are cancelled, you will get 1. That is why unit vector will be taking a cap equal to a bar upon modulus of a bar. That point we remind. Now for this, some problems based you can understood how to take the direction. Find the unit vector of a given vector. Here given vector is a bar. What is the given vector a bar? A bar equal to 2i cap plus 3j cap minus 4k cap. Here a cap equal to a bar by modulus of a bar. Magnitude find it first, under root 2 square plus 3 square minus 4 whole square. At any vector also magnitude is required. It's square of the x magnitude, square of the y direction magnitude and square of the z direction magnitude. They have the minus 4 beta, that is why here I taken minus 4 whole square only. This value is added, 2 square means 4, 3 square means 9, minus 4 whole square means 16. 16 plus 4, 20 plus 9, 29, under root 29 that is. Then A cap equal to A bar. What is the A bar? A bar means this vector can take. Denominator what have? Magnitude of A bar. This is the magnitude of A bar. That is only taken here. That is the for given vector, unit vector it is. Like you are calculating. But for example, generally unit vector where we are using specially means area will take. In second year topics, electric flux is there. In the case of electric flux explanation, area vector is required. Generally first thing is area is the vector or scalar means many members are responding about the point. Area is a scalar quantity because of you are taking as L into B like. But any point also can take. It is a square. This side A, this side also A. But it is a square plate or square shape of the lumen also can take, that is. Here square plate, what is the area? Area you can find A into A square it is. By the A square what you get? Magnitude you are getting. But how to take the direction for this? The direction of area is normal to the plane. Normal to the plane means this is area means it is the direction. It is normal to the plane. It is normal to that plane. This is acting outward direction it is. That is outward. Here in this 2D we are drawing the normal like. This dotted line what represents about this area normal to the plane. It is denoted with n cap. What is the n cap means? N cap is a unit vector, one unknown unit vector that is. Unit vector means its magnitude equal to 1 only that. Any magnitude is multiplied with a unit vector, there is no change in its magnitude. But magnitude is multiplied with the unit vector, the magnitude adding the direction, then the physical quantity will become a vector quantity. Here A square will give the magnitude, A square into n cap. Here area equal to A square into n cap. A square will give the magnitude, n cap will give the direction. But what is the n cap means? Unit vector it is. This unit vector, A square is multiplied with the unit vector, then what happened? There is no change in its magnitude, but additionally it is getting that direction. That is why it is area is the which quantity means vector quantity that is. Next, that is the use of generally unit vector. Next one more. A unit vector parallel to the resultant of the vectors A bar and B bar. Two vectors are given, one vector is A bar and another vector is the B bar. A bar vector is 4i cap, 3j cap plus 6k cap, and B bar vector is minus I cap plus 3j cap minus 8k cap. The resultant of A bar and B bar, R bar equal to A bar plus B bar. This is the resultant of the vectors. The vector sum of resultant always will take as the vector sum of the given vectors. Here given vectors are what? One is the A bar vector and another one is the B bar vector. Its vector sum can take it is. R bar equal to A bar plus B bar. Do you know the vector A bar? A bar plus write that A bar vector. B bar plus write this B bar vector also. Then B bar vector is what? Minus I cap plus 3j cap minus 8k cap. Here 4i plus 3j plus 6k. Here plus into minus minus, minus I cap plus into plus 3j cap plus into minus minus 8k cap. Here 4i cap minus I cap. 4i minus I 3i. That is 4 minus 1, just like algebra subtraction only it is. 3j, 3 plus 3, 6. Here 6 minus 8 have, minus 2 it is. But here we will do the addition only I cap magnitudes, or only j cap magnitudes, or only k cap magnitudes. Either we will do the addition or subtraction, but only I cap magnitudes, j cap magnitudes and k cap magnitudes only. Don't do the addition. 4 plus here 4 I cap 3j, 4 plus 3 7, ij वैसे मत करो कभी भी. Only I caps, only j caps, only in k caps, like we are taking. Then unit vector. What is the unit vector for that? Resultant vector is r bar. That's why r cap equal to r bar by modulus of r. First, find the magnitude of r. You know the formula for how to calculate the magnitude of r. Magnitude of r means general formula is what? Magnitude of r equal to under root x square plus y square plus z square. Here x, in the place of x what have? 3. In the place of y, 6. In the place of z, minus 2, that is. Here see r equal to under root x plus write as a under root x square means 3 square, y square means 6 square, plus z means there have the minus 2, that is why minus 2 whole square. You are doing that simplification here, root 49, that is equal to 7. Then r cap equal to r bar by modulus of r. Do you know the r bar vector? It is the r bar vector. Then do you know the magnitude of r also? 7, that is taken here. You understood, I hope. This is the explanation about this unit vector. Band karo first. The next one is displacement vectors. What is the displacement vector means? The difference between two position vectors is known as a displacement vector. Difference between two position vectors is known as displacement vector. It is drawn as arrow from the initial position to final position. It is the initial position, it is the final position. It is draw the one arrow. Initial position is A of x1, y1, z1. Final position taken as a x2, y2, z2. This length is denoted with that AB bar, that is vector notation only. But how to take the difference between the two position vectors we will see. This A bar, initial position vector, you can write either A bar you can take, or all positions are measured with respect to the origin. That is why OA bar also can take. OA bar equal to x1 I cap plus y1 j cap plus z1 k cap. It is the initial position vector. Final position vector can take as a OB bar. OB bar equal to x2 I cap plus y2 j cap plus z2 k cap. This is the writing the position vector with respect to given positions of the object. Initial position based I write one vector, final position based also I write one vector form. Next, same here also if you observe, the vector representation also taken in the 3-dimensional x-axis, y-axis, z-axis. In 3-dimensional coordinate system is considered here. First OP1, x1, y1, z1. Second one is P2 of x2, y2, z2, that is. The first vector name is r1 bar and the second vector name is r2 bar. Initial position P1 can take beta, final position can take as a P2. Particle is moving from the initial position to final position. Then when the particle is moving from initial to final, what is the displacement? Displacement means generally taken as a final position minus initial position. Here initial position based to vector form will write it. R1 bar equal to x1 I cap, y1 j cap plus z1 k cap. This final position based also vector form write it. R2 bar equal to x2 I cap plus y2 j cap plus z2 k cap. Initial position vector right and final position vector also have displacement vector. What is the displacement vector? Final position minus initial position. That is why here write R2 bar minus R1 bar. Then here taken R2 bar, this is the vector of R2 bar, x2i plus y2j plus z2k minus initial position is R1, x1i, y1j, z1k. Here only I cap terms can take beta. First x2, here x1, x2 here minus f, that is why minus x1 I cap, y2 minus y1 j cap, z2 minus z1 k cap. It will give the displacement vector. Now by this, one example also taken here. If a particle is moves from point 235 to point 345, its displacement vector is, what is the displacement vector? What is the displacement vector means? Here can take as a initial vector is OP bar. All positions are measuring from this origin only, that is why OP. Second vector is, our final position vector is OQ bar it is. Now position vector OP bar, what are the coordinates given? X coordinate is 2, Y coordinate is 3 and Z coordinate is 5. Then OP bar equal to write as a 2i cap plus 3j cap plus 5k cap. Here OQ bar equal to write 3i cap 4j cap plus 5k cap. This is the OQ bar vector also. Displacement vector means final position minus initial position. PQ bar, PQ means what? It is coming from that P to Q. That is why PQ bar vector taken. PQ bar equal to OQ bar final position minus initial position. Here OQ vector is there and OP vector also have. Just to substitute that OQ bar and OP bar. OQ value is what? 3i cap plus 4j cap plus 5k cap minus OP is 2i cap plus 3j cap plus 5k cap it is. Then here I cap, first see 3i cap, here 2i cap, 3 minus 2, 3 minus 2 I cap, 4 minus 3 j cap, 5 minus 5 k cap, 3 minus 2 I cap, 3 minus 2 value is 1, 1 into I cap, 4 minus 3, 4 minus 3 also 1 j cap, 5 minus 5, here plus 0 k cap also you can write, but it is 0 means you can leave also that. That is why the answer can take as a PQ bar equal to I cap plus j cap only, that is. Thank you. The next vector is polar vector. This polar vector, another name is called as a real vector also. This polar vector, another name is called as a real vector also that. What is the polar vector? The vector whose direction does not change even though the coordinate system in which it is defined changes is called polar vector or real vector. The vector whose direction does not change even though the coordinate system in which it is defined to changes. In case coordinate system changes also, the direction of the given vector does not change. Then the vector is called as a polar vector. Or polar vector, another name is called as a real vector. For example, here examples are given: force, momentum, acceleration. These are called as a polar vectors actually. But it is the x-axis can take, it is the y-axis can take. It's mean I consider as a just xy plane. In the xy plane, one force vector is taken, it is the force vector F bar. In the direction, one person given the force in the xy plane. For example, this xy plane is just rotated like, it is the new y-axis, it is the new x-axis. It means this xy plane is rotating an angle theta, but the direction of applied force there is no change. The direction of applied force is independent of this coordinate system. Then that is called as a, then the vector is called as a polar vector. If this coordinate system is changes, the force vector does not have any change. Next. The next one is axial vector. Actually, axial vector explanation is coming in the rotational mechanics, because of in rotational mechanics, torque, angular momentum and angular velocity, these all points also will come that. But here just what is the axial vector only will explain. The vector whose direction changes with the coordinate system in which it is defined to changes is called as a axial vector, or another name is called as a pseudo vector. The direction of vector changes by the changing that coordinate system. Here see, the vector whose direction changes with the coordinate system in which it is defined to changes, that vector is called as a axial vector or pseudo vector. Example, angular velocity, torque, angular momentum. Just torque equation just I will write directly, but to present not able to give the total explanation here about the torque. What is the reason for that? These quantities are coming in a rotational mechanics only. For that some more explanation is required. Just to explain, try to convey to you. Here torque tau equal to, torque is denoted with, it is denoted with the tau bar equal to R bar cross F bar. That is the vector form for the torque actually. This cross product also in the vectors only we will discuss. Next coming the concept R bar cross F bar. Here R to F can take. For example, pen cap for example you are taken, the cap will be rotated in anti-clockwise direction. The pen cap is rotating in anti-clockwise direction, the cap is moving outward. For rotation of the pen cap, we are applying the force. We are applying the force. Tangentially, we are giving the force on the cap. Then this cap will be rotating in anti-clockwise direction. It is anti-clockwise. Then the cap is coming outward. Same cap rotate in clockwise direction. Then the cap is moving inward. Here, cause of the rotation, based on one rotation cap is coming outside, based on one more rotation the cap is moving inside also. You can verify, once rotate the cap in anti-clockwise, it is coming outside or not, the cap is rotating in clockwise direction, it is going inside or not. By that, why it is moving we will see. It is the area of cross section of a pen cap. Area of cross section, just this cross section taken there. On this area of cross section, this is the center point, it is a radius. Radial outward direction. Actually up to here only the radius R, but force is given tangentially like. Here observe, force is given tangentially, it is the radius. Radius acting from the center to outside can take. Now force given upward, this is the R bar cross F bar. It is the anti-clock. When you are rotating anti-clock, the thumb represents outward, then this cap also coming outward. Same thing, it is the radius vector. Actually this length only radius. Just I am extending based on for explanation of direction only. Here force will give downwards. Here see that direction of force is changes. The previous coordinate system upward taken, it is downward like. Here system in which it's the coordinate system in which it is defined to changes. Just what is the change here? Force upward direction taken, here force downward direction taken by this only. Then R bar cross F bar can take. It is clockwise. When it is clockwise, the resultant acting inward direction that. Now the rotation when should be changes, the resultant vector direction should change. Here outward direction means here torque is positive direction, but here torque in negative direction. But this direction also here not able to take a hawa mein, in the air have that is. That's why this vector are called as a pseudo vector or imaginary vectors, those are called. Actually in the direction not given any force, but you are giving the force is tangentially, but this body is moving outward. It is moving outward, that it is have the direction, it is have the magnitude, but it is imaginary. You are can't able to show really. But previous case you are taken, here force you are taken or momentum taken or acceleration taken, these are also real things, but these are imaginary things. Angular velocity, torque, angular momentum are imaginary things. These are called as a axial vectors or pseudo vectors, its name is called. It is actually it is outward direction acting. Here it is inward direction is acting that. This torque is inward into the plane. Here this torque is outside the plane, dot represents outside the plane. That is called as a axial vector explanation. But clearly will come in rotational mechanics only, again that.